All right, so today we're going to be talking about properties of real numbers. So what we're going to start with is we're going to start by talking about the numbering system. So the first numbering system that everybody learns as a little kid is counting numbers or the natural numbers. 1, 2, 3, 4. Okay, so we tend to learn these numbers first as we're little, and then we have another numbering system that we learn later. So with the natural numbers, this is the kind of the smallest set of numbers that we're going to be talking about. Well, what we're going to do next is we're going to add in this number 0. Okay? So once we add in 0 to the set, this becomes the whole numbers. Okay? And its symbol is W. So all of the natural numbers are a subset of the whole numbers. Okay? So if it's a natural number, it is also a whole number. Okay? And now we have 0 and then the positive integers there, but we need some negative values. Okay? So we need the negation of all of these. So I need to have ... -2, -1, 0, 1, 2, ... And these are called the integers. And its symbol is Z. Okay? We use I for something else. Okay? So this takes care of all the positive, the negative integers. So these have no decimal. All right, so that's one of the things we want to make sure. Now, there's all these numbers that are in between there. Like, let's say I have ... -2, -1.5, -1, 0, 1/3, 1, ... So we have all these decimals. And one of the things that we want to look at here is this decimal is terminating, it ends. And this decimal here, so if I had 1/3, if I was to write that as a decimal, it would be repeating. It would go on forever and ever. So if we have a decimal that repeats or ends, this is called rational. So these are the rational numbers. And its symbol is Q. And each one of these is a subset of the next one down. So the naturals are a subset of the wholes are a subset of the integers are a subset of the rational numbers. So the rational numbers are all those decimals where they terminate or repeat. Now, what about all those numbers where they don't terminate or repeat, like pi? Well, pi, e, square root of 2, square root of 7, these numbers have decimals that do not repeat, they do not end, and so we have this set of numbers that is not part of these over here, and these are called the irrational. Okay, and it has a symbol of I. Now all these numbers here make up what we call the reals, or the real numbers, and its symbol is in R. Okay? So the nice thing about the numbering system is it gives us order. So we can take numbers and put them in order from smallest to greatest. So if I have here, if I had 1/2, -1, 8, 3, I can put these all in order. Okay? So I'm going to start here, I'm going to go smallest to largest, and I have order here. Okay, or -1 is less than 1/2, 1/2 is less than 3, 3 is less than 8. Okay, since we have order, we now can compare. So I can compare two numbers. So here I have the square root of 17, and I want to compare that to 3.8. Now, I may not know the square root of 17. I may not know what it is. Okay, but I can still get a comparison because I'm going to use some mental math. So I may not know what the square root of 17 is, but I do know that the square root of 17 is larger than the square root of 16, right? Because 17 is larger than 16. I do know the square root of 16. So 16 is equal to, the square root of 16 is equal to 4. And now I can take and compare this 4 to the 3.8. Well, I know that 4 is greater than 3.8. So since 4 is greater than 3.8 and the square root of 17 is greater than 4, the square root of 17 has to be greater than 3.8. Okay, so it allows us to compare numbers. Well, with our numbering system, we also have properties. So the first property I didn't write up there is closure. It just means that we're going to have a closed system. Okay, so now we have commutative. The commutative property essentially means that order doesn't matter. Okay, A plus B is going to equal B plus A. So if I have 2 plus 3, that's the same as 3 plus 2. It's very important that that works out. Same thing with multiplication. A times B equals B times A. They work out. The next one is the associative property. I can associate two numbers together through parentheses. Okay? So if I have quantity A plus B plus C, that's going to equal A plus the quantity of B plus C. So it doesn't matter where I put those parentheses as long as I have a string of addition. And the same thing holds true for multiplication. So if I have the quantity A times B times C, that's going to give me the same thing as A times the quantity of B times C. The next one is identity. Identity means getting back to yourself. Okay, so wherever I start with, how do I get back to that value? So in addition, A plus what number gives me A? Well, that number is 0. Okay, so 0 is our additive identity. In multiplication, we have a multiplicative identity. So I have A times what number equals A? Well, A times 1. Now the inverse is kind of how do I get back to that identity property here? So what am I going to add to A to equal 0? Well, A plus negative A, or 3 plus negative 3 equals 0. Multiplication says, what number am I going to multiply this by to get 1? Well, this is going to be a reciprocal. So if I started with a fraction, 2/3, my reciprocal then becomes 3/2, and that's going to equal 1. So I'm going to multiply by the reciprocal. The last one we're going to look at is the distributive property. Most of you are very familiar with this. If I have A times the quantity B plus C, this A multiplies each piece inside of that parentheses. So a lot of times you'll see me kind of go like this as a visual representation to show that I'm distributing A to both those values. So it becomes AB plus AC. So the last thing we're going to look at is identifying a rule. So if I have, let's say I have 3 times 4 times 5 equals 4 times 3 times 5. So we're going to look at these and kind of look to see what happened. So did I change the groupings of my parentheses? No. Those parentheses are still with the same numbers. So these look very, very similar, except the order changed inside the parentheses. Well, which one of these properties says order doesn't matter? So if we look here, we're in multiplication, so we're going to look at this column. Okay, commutative says A times B equals B times A. So this says order doesn't matter. So now we have the commutative property. Okay. All right, so that's properties of real numbers.